right, guys, are there any questions over any of the assignments so far before we start the notes today? So what we're doing today is we're doing a few more of finding the inverse of the function and then determining if two functions are indeed inverses. Now, we're going to start with this problem here. Consider the function f of x equals 2 times the square root of x minus 3. Then determine whether the inverse of f is a function and then find it. Well, if we want to determine if it's a function, we would graph it. We would graph the function, and this here actually does work out to have an inverse. Is this overall function, if I can draw, here we go, on the x-axis would start at the point 3. It would have this kind of graph, this overarching kind of little arc. And the reason that I kind of know that is because all quadratic, or kind of our square root functions, had this general shape. Now we know that what's inside the radical can't be negative, and the smallest value we can have is 3, because 3 minus 3 is 0, square root of 0 is 0. So that's where it's going to start, and we're going to go this way here. So that's more or less just to tell us that it does have an inverse. Okay, now we're going to find it. Now our first main step is to replace f of x with y. Our second main step is to switch x and y. Our third step is to solve for y. And then our fourth and last step was to replace y with f inverse of x. And these four main steps, we had them yesterday because we wrote these down yesterday on the first page. So I'm just rewriting them down so that we have them. And I did write them up on the whiteboard. Now, yesterday I might have said replace or switch, one of the two, but again, we're talking about the same thing. So when we look at this function here, our first step is to replace or switch f of x with y. So we're saying y is equal to 2 times the square root of x minus 3. Y is equal to 2 times the square root of x minus 3. Then what would we do? We switch x and y. So that would tell us that x is equal to 2 times the square root of y minus 3. Yeah, because you're probably on the next one. Okay, yeah, that'd make a little bit of a difference. Any questions on what we've done so far? I mean, we haven't done too much so far. Now we just need to what? Solve for y. We need to get y by itself. What's the first thing we can do? Divide by 2. Because we do have this square root that is connected with y, but we want to remove everything else away from that radical first before we simplify it. And we divide both sides by 2. We're going to get x over 2 is equal to the square root of y minus 3. Is everything else away from that radical? Yes, so we would put both sides to the second power. And the reason we do this is because the square root and square will cancel out. They'll simplify out, leaving us with y minus 3. Now on the left-hand side, we have x divided by 2 squared. I wouldn't want to leave it that way because that looks a little funky, especially with writing it. So we can go on and square the numerator and denominator because of our powers of a quotient. So we would square x. So if we have x squared, it's actually just x squared. Now the denominator is going to be 2 squared, and 2 squared is 4. Last but not least is adding 3. We're going to add 3 to both sides. And if we add 3 to the right-hand side, we do get y by itself. Can we add 3 to x squared over 4 easily? No? Okay. So I'm not going to. Because if they were like terms and we could actually add them, we would. And writing this as x squared plus 12 over 4 isn't any more simpler or any nicer than x squared over 4 plus 3. Because the only way that we could add them is making the denominators be the same. So we'd have to change 3 into 12/4 and then add them. But that's just as nice. Which is just telling us f inverse of x is x squared over 4 plus 3. And that right there is our inverse function. Any questions over this here? I forgot to mention this last hour, but x has to be greater than or equal to, is the range 0. Now, okay, I'm going to have to pull the graphing calculator up for this to explain this part. Now, for me, in this class, on this test, and the homework, I'm not going to be a nitpick about including that. Pause. Y equals, let's clear that out, clear that out, clear that out, and clear. Okay. 2 second square root x minus 3 is our function we had, yes? And that looks kind of like what we had or what I drew at the start. Now the x values for this here start at 3 and go towards the positive direction, yes? So technically the domain for this here would be all the values of x that are greater than or equal to 3. And if we looked at the table, we would see at 3, we do get a y value of 0, and then it increases from there, yes? So the range of the function that we started out with, so the domain of the beginning function, and it would scroll, is x is greater than or equal to 3. And the range is all the y values that are greater than or equal to 0, yes? Because they're all in that top right quadrant. Now the inverse function, because our normal function is taking it from the domain to the range. The inverse is taking it from the range to the domain, yes? So the range values that I'm restricted to are all the values that are greater than or equal to 0, yes? That means the domain of our inverse is restricted to all the values that are greater than or equal to 0. Because if I type this in, y squared, x squared over 4, alpha y equals, enter, x squared over 4 minus 3, or not minus 3, it would be plus 3, and I graphed it, well, we have this quadratic, yes? Does it include the positive and negative zeros? Well, yes. All the values of x that are in the negative side are actually a part of the function that would have been below the x-axis. It would have been those values. Well, since we didn't include them, we can't necessarily include those either. So we'd have to add the restriction that x has to be greater than or equal to 0. But in here, I'm not so much focused on this. I'm more focused on, can you find this? Okay. Now for an algebra or college algebra class, most likely they'll throw that in, making sure do you remember to put this part. Any other questions on finding the inverse, not so much the restriction? Are you good for finding the inverse? The restriction makes sense when we look at the graph, yes? All right. Let's look at this one here. F of x equals 3 times the square root of x plus 4. So we can first replace f of x with y. 3 times square root of x plus 4. And then we would switch x and y. Now we need to solve for y. The first thing we can do in solving for y is to divide both sides by 3. And if we divide both sides by 3, we get x over 3 equals the square root of y plus 4. Then we would square both sides. And if we square both sides, well, on the right-hand side, we have y plus 4. On the left-hand side, we have x squared over 9. Extend the page a little bit. Last but not least, subtract 4 from both sides, which will tell us that y is equal to x squared over 9 minus 4. So our f inverse of x is x squared over 9 minus 4. Any questions on this here? Now what's interesting with inverses is we're doing the exact opposite of what we did to the original function, because we're going backwards to get back to where we started, yes? So here, when I explain this through, we can think of this as x over 3 squared. You don't have to write that down. But if we look at the original function, okay, I'll just write it over here. F of x is equal to 3 times the square root of x plus 4, yes? Now, if we plugged a number into this, the first thing we would do is add it to 4, then take the square root, and then multiply that by 3, yes? So we're going in kind of a reverse order. So if I'm going in the reverse order, what is the last thing I would do to this function? I would times it by 3, yes? We're going the opposite, so I wouldn't multiply, I would divide by 3. Then after that, we took the square root. To undo it, we would square. We added 4, so then we would subtract. The inverse is just going backwards of what we would do otherwise and applying all the inverses to it. Does that kind of make sense? So a lot of times when we look at some functions, especially if it's asking this on the ACT, okay, well, the last thing I know is I'll divide by 3. So whatever the inverse has should have a division of 3, and then squared and kind of applying those there. So when we look at the answers, we can eliminate the ones that don't work. Any other questions on these here? All right. We'll look at this one here. This is the last one we'll find the inverse of. And then we're going to test them. We're going to test to see if two functions are indeed inverses of each other. Now that kind of step through way does work here, but it's a little funky, especially with the negative. Because if we were working this backwards, well, the last thing I would do is we add 4 to it, so I would subtract 4. Then we would have had the negative, so it would have made it positive, and then cubed. But let's go on and work step by step through. Now the first main step would be to replace it with f of x with y, yes? And then switch. Now, I have a feeling when I said the first thing we're wanting to do, y'all are already starting here, yes? And that's fine. Because if writing the step in red isn't something that you necessarily need in solving it, that's fine. Jump straight to the one that I wrote in black. Because if we know, okay, it's going f of x is y, and I'm going to flip it, change, flip, do it at the same time. There's nothing wrong with that. If jumping straight to that's confusing or it's hard to keep straight, go and write the one in red, then write the one in black. Go on and rewrite f of x is y and switch. Now, once we get here, we would subtract 4 from both sides, telling us that negative y cubed is equal to x minus, x minus 4. Then what would we need to do? We need to divide by negative 1 or multiply by negative 1. I like the multiplication because it's a little bit easier to see, or we can think of it as that I'm changing y cubed to negative y cubed to positive y cubed. I switched its sign. So the x is going to go from positive to negative, and the 4 is going to go from negative to positive. And the last thing we need to do is take the cube root of both sides, which will tell me that y is equal to cubed root of negative x plus 4. So f inverse of x is equal to the cubed root of negative x plus 4. And that right there would be our function. Our inverse anyways. Any questions on any of this here? Any questions over anything we've done so far? All right. If there's no questions on this here, we'll move on. Because this here, if you wanted to work it, f inverse of x, which should give us x squared minus 2 if we work this out. But I'm throwing that up there because we're going to go on and move on to the next and last thing we're covering. Verifying functions are inverses. So we're given 2 functions, and we want to verify that they are inverses. So can we say that f of x equals 3x minus 1 and g of x equals x plus 1 divided by 3 are inverses? Well, yes. And the reason I can say that, well, I did it last hour, but also the directions say to verify. Verify is just another way to say to show that they are inverses. So these are inverses. We just need to show that they are. Well, before we do this, you don't have to write this down. But as I did yesterday, I'm going to draw a picture. Now our domain values are our x, and the range values are our y. And when I have function f of x, it's going to take a value from the domain and map it to a value of the range. It's going to take us from one domain value to one range. 1x for 1y, yes? Now the inverse of it is taking that y value and bringing it back to the input, back to what we started with, for any given value. And we saw that the other day when we did the input-output, where I could use the inverse to find out what the input was. We can plug that input in to find out what the output is, go back and forth. Yes? Now, here, I'm not going to call this f of x. We'll call it g of x. Now, what's interesting is if I take f of g of x for this here, and this setup, well, g of x, because this here it's calling x, is going to take me from the range to the domain, just giving me this kind of f of x value. It's going to take me over here. Well, f of x is going to take me right back to where I started. Well, if there are inverses, it's going to end up where I start, which for us will most likely end up being x. For here, we could say y. Now, g of f of x, well, f of x is going to take me from this domain value to this certain range. And then applying g of x to it is going to take me back where I start. They're going to undo each other. And what that means for us is if these two functions are inverses, then f of g of x and g of f of x should give us the exact same thing. More specifically, they're going to give us x because they're undoing each other. They're the opposite operations. As I remembered, I just plugged these in because we said that these are inverses. We found it. So the first one is our function. So here, when x is 3, the value of y for f of x is 0. If I plug that 0 into the inverse, where do I get back to? 3. I get back to the x value I started with. They will undo each other if we take the composite of these functions. Now, if we look at the first one, f of g of x, well, the function g of x in our case is x plus 1 divided by 3. So we'll replace g of x with x plus 1 divided by 3. Now, just like we did composite functions the other day, now we're going to plug the x plus 1 divided by 3 in for all the x values, or all the x's in f of x, which this here would give us 3 times x plus 1 divided by 3 minus 1. Any questions on this so far? Now we just need to simplify this. Well, whenever we multiply a whole number by a fraction, the whole number multiplies by the numerator. Now, normally I would distribute that and do 3 times x and 3 times negative 1. But if I just multiply by that 3, don't we have a 3 divided by 3 here? And 3 divided by 3 is 1. So that just tells me that I have x plus 1 minus 1, which is so we're halfway there. We're able to show that f of g of x is x. They undid each other. So our f of g of x is equal to x. Let's look at g of f of x. Well, f of x is 3x minus 1, so we can replace it with its function. And just like we did with f of x, we're going to replace any x in the function g of x with 3x minus 1. So what that would give us is 3x minus 1 plus 1 divided by 3. Well, do I need those parentheses in the numerator around 3x minus 1? Not really, because there's nothing being multiplied. I don't have to distribute any negatives. We can just drop them, which would give us 3x minus 1 plus 1 over 3. Negative 1 plus 1 is, so I just have 3x over 3, which is simplifies to x. So g of f of x is also x. So can we say these two functions are inverses? Yes. Because f of g of x is equal to g of f of x, which is equal to x. And as I said the other day, there is a certain group of functions that their composites would be the same, and inverses are them. Inverses are the main time that the composites both work. Questions on this here? No questions on this here? Any other questions on the inverses or verifying? Let's look at the next one, not this one. Can we say that these two are going to be inverses? Well, not really, because what are the directions? Determine. If we're determining something, we need to show either yes or no. Because unlike verify, verify is telling us that they are. Determine, not so much. So here we want to see if f of g of x gives us the same thing as g of f of x. F of g of x and g of f of x give us the same thing. Now luckily these are actually quite simple to do. Because for us here, g of x is what? X minus 5, yes? So we replace g of x with x minus 5. Now at this point here, we're going to plug x minus 5 in for x and f of x, which would give us x minus 5 plus 5, which is x minus 5 plus 5, which gives us x. This is negative 5 plus 5 is 0. That's all we have to do for that one there. Now it is good to always check both to make sure one, just the off chance that one works but the other doesn't. For this one here, f of x is x plus 5. And again, just like with the first one, we're going to plug x plus 5, or take x plus 5 and replace it for every x in g of x, which would give us x plus 5 minus 5, which is x plus 5 minus 5, which equals x. So are they inverses? Yes. Is f of g of x is equal to g of f of x, which is equal to x. They are inverses. Any questions on this here before we look at the last one? Last problem of the day. Determine whether f of x equals 8x cubed and g of x equals the cubed root of 2x are inverses. Which one do we want to look at first? F of g of x or g of f of x? Doesn't matter. F of g of x. Now in our case, g of x is the cubed root of 2x. So we'll replace g of x with what it's equal to, the cubed root of 2x. Now again, just like on the last ones, we're going to replace every x in f of x with the cubed root of 2x. Now this will give us 8 times the cubed root of 2x cubed. Now this one here is kind of nice because the cubed root and the cube will cancel each other out. They'll simplify each other out. Which gives us 8 times 2x. And 8 times 2x is that what we wanted? No. So can we say these are inverses? No. I don't even have to do the other one because since this one did not give me x, I know immediately it's not going to be inverses. They're not going to be the same. Now, if I wanted to find it, g of f of x, we would replace f of x with its function, 8x cubed, and then plug that into g of x, which would be the cubed root of 2 times 8x cubed. Two times 8 is 16, and we have x cubed. Now I know I can take the cubed root of x cubed, because cube and the power match up. Now the cubed root of 16 doesn't quite work, because 16 is 2 to the 4th. Well, we can take 1, 2 out, but what I'm left with is the cubed root of 2, because I can bring a group of 3 out, but I'm left with 1 left over. So we can see here, these are not the same. These are not inverses. If they were, one of the functions g of x would actually have to be the cubed root of x over 2. The 2 would need to be outside. For 16x, yeah, the 3 and x to the third do simplify, but our 16 is 2 to the 4th. So we can, because 16, this is the same as saying the cubed root of 8 times 2. Cubed root of 8 is 2, but I'm left with a 2 inside. We can't fully take the cubed root of 16. We can take the 4th root of 16, but not the cubed root. Does that kind of make sense? Are you wondering where I got that? Oh yeah, because 16, if we could, this would need to be rewritten as something to the third, then we can cancel them out completely. But because 16 is really 2 to the 4th, they don't just cancel out nicely. Does that make more sense? Yeah, and I got g of x from taking the inverse of f of x. Any other questions on this here? Now, if we wanted to find out what f of x, if g of x actually was the cubed root of 2x cubed, would be, well, apparently I'm going to do that. X cubed over 2, if we wanted to go the other way around. X cubed over 2. But that's all we're doing for this here, 289. So this is on page 289.